Morning Seeders. In today's exam video we're going to have a look at a question that asks us to analyse a graph. This is a really common question type in GCSE science exams. The first thing that we're going to do is we are going to read the text above the graph. A remarkable number of candidates fail to do this when presented with graphs and diagrams, and so my first tip for you is always read the blurb above the graph or the picture. Megaphones can produce very loud sounds. No kidding. A person's hearing can be affected by age and by working in a loud environment. Figure 4 shows how frequency affects the minimum sound level that can be heard by 3 different people, A, B and C. So we have already in the blurb been told that we're looking at a person's hearing and the effects of age, working in a loud environment and frequency. If we take a look at the graph, we should always look at the labels on the axes first. So the y-axis, we have minimum sound level that can be heard in arbitrary units. Arbitrary just means don't worry about the units. We're given a magnitude, that's all you need to worry about. The x-axis has frequency of sound in hertz. And then we have some additional variables because we've got person A, person B and person C. We have their ages, so persons A and B are both 50, whereas person C is 25. And we have the environments they work in. Person A is in a loud environment, whereas persons B and C both work in quiet environments. Let's have a look at the question. Compare how different factors, that's factors plural, affect the minimum sound level these people can hear. So, we are being asked to have a think about how frequency affects minimum sound level, how age affects minimum sound level that can be heard, and how the environment a person works in can affect the minimum sound level that can be heard. So there should be 3 sections to our answer if we want to score full marks. I would always start with the variable that's on the x-axis, so frequency. In this case we can see that for all 3 of these people, as the frequency increases, the minimum sound level that can be heard also increases. So in all 3 cases we have an upward trajectory. So the first part of our answer we would say as frequency increases, the minimum sound level that can be heard also increases. Next I would tackle the ages. So we've got 2 50-year-olds and a 25-year-old. It is really clear from this graph that as your age increases, so does the minimum sound level that can be heard. So we have a 25-year-old at 2000 Hertz, they can hear a minimum sound level of 11, whereas persons B and A, our 50-year-olds, are way up here at 24. And then at every single frequency along the way, the minimum sound level that can be heard by the 25-year-old is lower. So as age increases, so does the minimum sound level that can be heard at all frequencies. There is another subtler difference, which if you're looking for 4 out of 4, you would be expected to pick out. The variation in minimum sound level that can be heard for the 25-year-old is actually very small. It goes from 11 to 15, so there is only a variation of 4. For this 50-year-old, we're going from 24 to 35, so a variation of 11. And for this 50-year-old in a loud environment, we can see it's way greater than that. So they're going from a minimum sound level of 24 to 61. So we would say that when you're younger, the variation in minimum sound level that can be heard is much smaller than in our 50-year-olds. The final variable that we should be looking at is the environment in which the person works. So we compare A and B, and we can see that at every frequency above 2000 Hertz, the minimum sound level that can be heard is greater in the 50-year-old who has worked in a loud environment than the person working in the quiet environment. We should note that the minimum sound level that can be heard is the same at 2000 Hertz. And again, A subtler, more nuanced answer would include the fact that between 2000 and 4000 Hz, we have this big difference in minimum sound level that can be heard, and that then levels off at over 4000 Hz. These questions can be tricky because of the number of variables that are included, and as well as encouraging you to always read the blurb above the graph or the picture, I would encourage you to carefully read all of the information before attempting the question, so you get it clear in your head how many things you are expected to talk about. In this case, we had frequency, age, and the environment. I hope the video was useful. If it was, please do subscribe. This is Mr. Rolf signing off.